Hello, in this video I'm going to talk about vectors in two dimensions. So we've already defined what a vector is, so let's start actually using them. So here we have the vectors that we saw before, and the vectors would be 4, 6, that would be vector u over here, and we'd have 0, 5 for vector w, 1, 0 for z, and 4, minus 4 for v. So in three dimensions, how would this be? Well, in three dimensions, I have the same ones here. Now these ones are just seen from the top, and this blue thing here is actually a new axis that's going towards you. So for that axis, I could just have a 0 for the z coordinate, or a 0 for the u coordinate, or a 0 for the z, or a 0 for the v. Now, what would happen if it would change? It would be something like this. This is vector u, the one that I have over here, 4, 6, 0, and this is vector u with a different coordinate in the z-axis, and here with a different coordinate in the z-axis. You can see how this works. And that's how we add the third dimension. Now let's see a few more things. For example, how do we calculate a vector? Now think about it. The vector is just the movement to go from one place to the other. Now, for example, here is the way to go from Puerta del Sol to the school, just taken up from Google Maps, right? Now, if I was to tell you, well, like let's figure out from Majadahonda to the school what it's like, and I happen to have what it's like from Puerta del Sol to the school, and I want to know the vector to come from Majadahonda to the school. All I have to do to know how to go from point A to point B is to figure out the route from the origin to point B and subtract the route from the origin to point A, and I'm going to be left with the route that I'm interested in. That's exactly how we're going to do things with vectors. So to find a vector, if you want to find the coordinates of the vector that goes from P to Q, all you have to do is take the coordinates of the destiny, in this case Q, and subtract the coordinates of P. So the vector that goes from P to Q is vector 2, 4. Will be a vector like this. And in three dimensions, we're going to do exactly the same thing. So go from P to Q, we're just going to subtract origin from destination. So you're going to go from P to Q, take the coordinates of Q and subtract the coordinates of P. And you're going to get the vector that goes from P to Q. That's how you have to move to go from P to Q. And there you go. So in fact, the thing is that most rules and tricks you learn for 2 dimensions are going to work in 3 dimensions. So how do we calculate the length of a vector? Well, if you're using 2 dimensions, you can use Pythagoras, right? If you want to know how long this green line is, right? How long you're going to be traveling for, you can just use Pythagoras, because you have the length of this side of the right angle triangle, and you have the length of this side of the right angle triangle. So you can calculate like this. And again, 2-dimension rules work in 3 dimensions. So if you want to calculate the modulus, or how long this vector is, all you have to do is the square root. And this, of course, you have it in the formula booklet, so no need to memorize. There's one more thing you can do with this, which is calculate a unit vector. So essentially what a unit vector is, it has to be the same direction, it's going exactly the same way, but the modulus must be 1. So we're looking for a vector that essentially moves in a particular direction that has modulus 1. So for example, if I have this vector here, what's the modulus? Well, again, this is Pythagoras, it is square root of 14. So how do I find a vector that has exactly the same direction as this vector here, but modulus 1, not modulus square root of 14? Very simple. All I have to do is divide. And now this vector here will have modulus 1. This is easy, and they might ask you to do it. It seems very simple. The problem is that it's not in the formula booklet, so you're going to have to remember how this is done.